Okay, so I'm going to go over these review questions on the multiple choice format and kind of help you get ready for the test. There are 20 multiple choice on the test and 5-word problems. Okay, so the first one says that acceleration and reaction forces occur anytime. So let's get a pen over here and whether there's motion or not, because if you have a box setting on the table, you have the earth pulling down on the box, that creates the weight. You have the table pushing up on the box, so that's my action reaction. Two different objects, the earth and the box, and it's not in motion, but there's action reaction. Same thing happens when something is moving. Let's say a ball rolls towards you and you kick it with your foot. So the foot exerts a force on the ball, and the ball exerts a force back on the foot. You're sitting in a chair, and that's an example of Newton's first and third laws, because for every action there's an equal and opposite reaction. And you're not accelerating, so it can't be that one or that one. There is not a fourth law. And the third law says, or the first law says that you're going to keep on doing whatever it was you were doing unless acted on by an unbalanced force. Golf ball and a bowling ball are moving at the same velocity. This has to do with momentum. That won't be on the test, but I will just tell you that momentum is mass times velocity. Wow, that's crazy. Mass times velocity. The bowling ball has more mass, so it has more momentum. But again, we're not going to worry about that for the test. How much force is needed to accelerate? So we're looking for F. The mass is 270 kilograms. And we want to accelerate it at 4 meters per second squared. So if I multiply 4 times 270, I'm going to get 1,080. So there's the correct answer. When an airplane takes off, you tend to fall backward because of inertia. Because your body was at rest, it wants to stay at rest. The airplane wants to move forward, so you move backward. Same thing happens when you're sitting in a car and you don't realize someone's fixing to accelerate forward. You fall backwards. All right, so let's go on. There we go, number 6. Number 6 says Newton's third law of motion states that if a force is exerted on an object, another force occurs that is equal and opposite in direction. Blank is a measure of inertia, mass. It's in kilograms. The more massive you are, the more inertia you have. Inertia is a change to the resistance of your motion. So think about a refrigerator as compared to a coin. It's much harder to change the state of motion of the refrigerator than the coin. Use Newton's second law of motion to calculate the acceleration. Well, acceleration is equal to force over mass. The net force is 68.6 newtons. It's acting on a 7-kilogram object, so that would be 9.8 meters per second per second. Newton's third law of motion states that whenever one object exerts a force on a second object, the second object is going to exert a force that is equal and opposite on the first. All right, so let's move on. According to Newton's first law of motion, a moving object that is not acted upon by an unbalanced force will remain in motion forever. What force is necessary to accelerate a car? Well, the force is equal to mass times acceleration. Car has a mass of 1,250 kilograms. Acceleration is 40 meters per second squared. If you multiply 40 meters per second squared by 1,250, you're going to get 50,000 newtons. A 5-kilogram object has less inertia than a 6-kilogram object. All of these have less inertia than the 5, but that's not what they're asking you. They're asking you the 5 has less than what? Well, the 6. All right, so let's move on down. Here's another one over momentum. Again, momentum won't be on the test, but it's explained by Newton's second law of motion, which I will teach you. When gravitational force changes, well, that's just weight. So if your weight changes, it's because the gravitational force has changed. If you want acceleration, acceleration is Vf minus Vi over T. A force is expressed in newtons, can cause an object to speed up, slow down, or change direction. Is a push or a pull, so it's all of those. Acceleration of an object decreases as the mass increases, increases as the force increases, is in the same direction as the force, all of those. Newton's second law states that an object's acceleration will increase if the mass goes down, and will increase if the force acting on it increases. Inertia is used for explaining Newton's first law of motion. A soccer player places a soccer ball at rest in front of the goal, lines up her shot, runs up on the ball, and kicks the ball as hard as she can. During the contact of her leg with the soccer ball, the force of her leg on the ball is equal to the force of the ball on her leg. For every action, there's an equal and opposite reaction. Number 21 says a 10-kilogram brick and a 1-kilogram book are dropped near the Earth's surface. The acceleration due to gravity is the same for both of them because it's 9.8 or 10 meters per second squared. Mr. M pulls Fluffy across the floor by her leash, accelerating her at a constant rate. She digs in her claws, applying a force that balances the pull of the leash so there's no more acceleration. Compared to an object weighing 10 newtons on Earth, an object on the moon will have the same amount of inertia because that's related to the mass, and the mass doesn't change. Oop. Not true. Let me go back. If it weighs 10 newtons on Earth, it has a mass of, let me think about this, 10 newtons divided by 10 meters per second squared is 1 kilogram. If it's on the moon, the mass on the moon is going to be the weight of 10 newtons divided by gravity, which is 1.67 on the moon. So this one will have whatever 10 divided by 1 2/3 is, I think that's 6 kilograms. So it's going to have more inertia on the moon because it weighs more there. I mean, its weight is still the same as what it was on Earth, but the acceleration due to gravity on the moon is much less, so it's going to have more mass, which is more inertia. 10 kilograms on Earth, 10 kilograms on the moon, same inertia. The moon is attracted toward the Earth by a large gravitational force. The Earth is attracted toward the moon by a force that is exactly the same. For every action, there's an equal and opposite reaction. One more because we're throughout 27 and 28. So what we know is that a force accelerates a mass at a constant rate. If the mass were doubled, so the acceleration got cut in half, and the force were half, so the acceleration got cut in half, a half times a half would mean the acceleration would be 1/4, which is quartered. Okay, please study.